This lesson is going to be about VSEPR theory, or the valence shell electron pair repulsion theory. I know it's spelled VSEPR, but we call it VSEPR. It states that the repulsions between valence electron pairs causes the electron pairs surrounding an atom to move as far from each other as possible. Remember, the electrons don't like each other, so they're going to be as far away as possible. They are the same charge, so they will repel. This causes molecules to take on one of 5 basic shapes. The Lewis dot structure of a molecule can be used to determine the shape of a molecule. So the 5 basic shapes are linear, bent, trigonal planar, trigonal pyramidal, and tetrahedral. Sometimes you'll see triangular planar and triangular pyramidal, but I think that's kind of a mouthful. It's totally okay to say trigonal planar and trigonal pyramidal. Now, I will tell you that A, B, and E right here are A is the central atom, B is the outside atom, and E are lone pairs. That is the general formula that's going on in this column, in this area right here. So now let's take a look at a simulation. To help you see this, try to see this in 3 dimensions. So here's our central atom, that's the purple one. And then we're going to put a bond around it, and so here's our linear atom. Okay, we only have 2 atoms. The only way they can work is if they're linear. And then if we put another atom around it, it is still going to be linear. It is 180 degrees from each other. So you can see down here in the bottom left corner, the molecular geometry is linear. Now the next one is bent. So if we add in a lone pair, those lone pairs are electrons, and they're going to repel the electrons in the bonds. So they're going to make it about 120 degrees, and they're going to bend the shape. Now, if you look, this is just you don't pretend that the electrons are invisible, and you're just seeing an atom here and an atom on the left and an atom on the right. So it's kind of that bent shape. That's why we would call that bent. And then if we add even another lone pair, the angle becomes smaller, because the lone pairs are going to repel even more. So now this is what water would look like. Oxygen in the middle would have 2 sets of lone pairs, and it has 2 oxygens on the outsides. So that is the 2 bents. Okay, to be bent, it has to have lone pairs on the central atom. Now the next one is going to be trigonal planar. You'll see right here in the bottom left corner it says trigonal planar. That is with a central atom and then 3 bonded atoms on the outside. Now note that it doesn't matter if it's a single bond or a double bond or a triple bond. Bonds are bonds. So bonding pairs will make the same shapes. It doesn't matter if they're single or double or triple. Just an FYI. And then now, if we add in a lone pair, we get a cool little shape here. And this is my favorite one. It looks like a UFO landing or something, where you have this little tripod of trigonal planar, or trigonal pyramidal. So it's like a little pyramid. It kind of stands up. And with the lone pairs on top, the lone pairs will bend these atoms down. So that is trigonal pyramidal, and then the last one is tetrahedral. And if you have 4 bonds around the central atom, then it will be tetrahedral with no lone pairs. Now we're going to take a look at them on a 2-dimensional scale and on paper. And we're going to take a look at the Lewis structures. So this is what's in your notes. We have the linear ones. And so that would be like F2, and we just draw the Lewis structure here. Now we have AB2, and this is BeCl2. So it would be beryllium, and then we would draw chlorines on the outsides. Now the lone pairs on those outside atoms doesn't really go into the shape. We're only really looking at that central atom right there. Now this one is a very unusual one. And it's hard to find an example of something with only 1 lone pair, but this is a good one. This is selenium dioxide, and it would only have one lone pair on 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 the on the central atom. Now that one doesn't happen that often. The one that happens the most often is two lone pairs on the central atom. That would be water. Okay, so note that we're getting that bent shape. We're showing that bent shape. Trigonal planar, BF3, that we're going to have boron, and then we're going to have fluorines here on either side. And then we're going to try to place those dots around it as far away as possible. Trigonal pyramidal, we're going to put that nitrogen here. And now this is how you can do it, just in case you see this. You can see a wedge right here, and then a dash, and then a line. So the wedge is coming towards you, the dash is going away from you, and then the line is in the paper. If you don't like that, you can just draw it without that. You can just draw lines. It's the same thing, no big deal. And then the tetrahedral one, I'll draw the normal one. We have C. A lot of people like to draw this. However, to get the shape just right, you would want to draw a hydrogen on top, and then a hydrogen here, and then a hydrogen as a wedge, and then a hydrogen as a dash, because that hydrogen is going away from you, and this hydrogen is coming towards you. So the shape it would look like would be like that. All right. So that is the VSEPR theory, and we'll do that to be able to do our shapes lab.